Hey everyone, and welcome back to Edritt. In this lecture, we are gonna study how we can convert the binary numbers to hexadecimal and octal numbers. Okay, this is exactly just opposite of what we studied in the very last lecture, and you also don't need to put much mind. It's just doing the opposite way, which we did in the previous lecture. So before wasting our time, let's start this lecture to understand how we can do that. So in order to do binary to octal conversion, this is the steps which you have to take in account. So basically, firstly, whatever the binary number you have given, you have to make the combination of 3 bits each starting from LSB. Now, if the MSB of the binary number lacks bits, simply append zeros. Now this capital B, don't get confused, it represents bits, not byte. Now, now, what you have to do, you have to simply look at that sequence table and then write the octal equivalent of each combination. Maybe it would be hard for you to understand, but let's directly jump into an example. So I'll take a random binary bit, which is binary number, which is 101100010101 point 110101. Okay, 1011. Okay. So now let's try to convert this binary number to octal number. We'll first move to the step one, which is make the combination of 3 bits starting from LSB. So we'll move like in this direction. So when we move in this direction, what we will do, let's try to write down these combinations separately. So I'll say 101 one combination, and then 010 another combination, and then 001 another combination, and then 101 another combination. Okay, I'll also append one over here. So you see this one. So these combinations are done. This one is done. I'll use different color. So this combination is done. This combination is done. This combination is done. This combination is done. This is the only left bit. So how I need to approach this problem? Simply I'll do 001. Okay, I appended zeros after this MSP, most significant bit. Here also I'll start 110. Okay, so one combination, 101, one combination, and then this one is left out. So what I have to do, I have to append zeros rightwards. Okay, so all these three combinations also done here. One combination, two combination, and third combination. Now what you need to do, you need to look at the table and write the octal equivalent. This is the table which we studied in the last lecture, right? So look at this table, find the equivalent octal of each binary 3-bit binary combination and write it down. So 001 has the binary equivalent of 1. 101 has, sorry, octal equivalent. 101 has the octal equivalent equal to 5. 100 has octal equivalent of 4 point, sorry, no point. 1010 has this octal equivalent of 2. 101 again, this has octal equivalent of 5. Point 111 has this octal equivalent of 7. 101 has this octal equivalent of 5. 100 has this octal equivalent of 4. That's base 8. You have successfully converted a binary number into an octal number. Easy, right? Let's quickly see hexadecimal also and then conclude this lecture. So again, binary to hexadecimal conversion requires same step, except the fact that here you have to make combination of 4 bits instead of 3. And again you need to append zeros, and those zeros should be such that the combination for the MSB becomes 4-bit long. And then you have to simply look at the table and write the hexadecimal equivalent of the combination. So again, let's take an example. I'll take an example of 11011 1011 110000 1.11001000100. Okay. Now, in this case, I need to convert this into the equivalent hexadecimal number. What I need to do, simply follow the steps and the answer will be there. So first of all, I have to make combination of 4 bits. So 1, 2, 3, 4, 4 bits. Then 1, 2, 3, 4, 4 bits. Then 1, 2, 3, 4, 4 bits. And then 1, 2, 3, 4, 4 bits. I'll append one more bit so that I can make you understand the next thing also. So I append this 1. So I need to put additional zeros over here so that I can complete it out. So now this one is also complete. Similarly here 1100, then 1000, then 1100. Okay. If there was additional, you just need to append zeros such that the combination becomes of 4. Now I need to simply write the hexadecimal equivalent of each of this combination. Now the hexadecimal equivalent of 1 is what? It is 1 only. Hexadecimal equivalent of 1101 is what? Go to this table and see 1101. 1101 is D. So I'll simply write D. Now 1101 again, same combination D. Then 1110, go to this table and see 1110 has equivalent E. So I'll write down E. Now this 0001 has equivalent 1.1100. The equivalent of 1100 is C. So I'll write down C. Then 1000, equivalent of 1000 is 8. So I'll write down 8. Then the equivalent of 1100 is C. So I'll write down C and then I'm done. This is the hexadecimal equivalent of this binary number. I hope you liked this video and understood the concept of conversion from binary to hexadecimal, and in the previous lectures the conversion concept of hexadecimal and octal to binary. I hope to see you in the next lecture. Thank you. Bye bye.